السلام عليكم ورحمة الله تعالى وبركاته. In this video we will solve together a new problem concerning the natural logarithmic function, and we are going to solve this problem question by question. This is problem number 2. Consider the function f defined as f of x equal ln x minus 1 over x. See its representative curve. We are going to calculate limit f of x as x goes to 0 plus and limit f of x as x goes to plus infinity. Limit f of x as x goes to 0 plus, ln 0 plus minus infinity over 0 plus, this is minus infinity. Or we write limit f of x as x goes to 0 plus, it is 1 over x times ln x minus 1 as x goes to 0 plus. 1 over x is plus infinity, and ln x minus 1 is minus infinity. Plus infinity times minus infinity equals minus infinity. Limit f of x as x goes to plus infinity, this is limit ln x minus 1 over x equals 0 because x is faster than ln x as x goes to plus infinity. So here we have a vertical asymptote and a horizontal asymptote. Vertical asymptote x equals 0, horizontal asymptote y equals 0. Verify that f prime of x equals 2 minus ln x over x square. F of x is u over v, so f prime of x is u prime v minus u v prime over v square. U prime 1 over x. 1 over x times x minus v prime 1 times ln x minus 1. Okay, this is 2 minus ln x over x square. Set up the table of variation of f. F prime of x, take the sign of 2 minus ln x. How to study the sign of 2 minus ln x? We have one factor and one minus, so we start the table of sign by plus. 2 minus ln x vanishes at x equal e square. F of e square is 1 over e square, so the table will be like this: x 0, e square plus infinity. The sign of f prime of x over 0 e square plus e square plus infinity minus, and at e square 0. Increasing, decreasing. If x equal e square, f of e square 1 over e square minus infinity 0. This is the table of variation. Write an equation of the tangent t to c at the point of abscissa 1. The slope of this tangent is f prime of 1. We calculate f prime of 1. This is 1. This is 1. The equation of the tangent is y minus y point equals slope x minus x point. Y point equals minus 1. It is f of 1 because the point belongs to the curve. Substitute. We get t of equation y equal x minus 2. Verify that the tangent t prime to c at the point of abscissa e is parallel to d y equal 1 over e square x plus 3. So we have to prove that slope of t prime equals the slope of d. Slope of t prime equals f prime of e. Let us calculate f prime of e. This is 1 over e square equals slope of d, then t prime parallel to d. So here we have a function u defined over 0 plus infinity, ln x plus 3ax square minus 2. or 3e square x square. Prove that u is strictly increasing over 0 plus infinity. We have to calculate its derivative. Its derivative, u prime x equals 1 over x plus 6e squared x, because the derivative of x squared is 2x times 3e squared x, which is positive. 1 over x is positive, 6e squared x is positive. Then the function is strictly increasing. Calculate u of 1 over e. U of 1 over e, we have to substitute x by 1 over e here. So ln 1 over e plus 3e 1 over e minus 2. Ln 1 over e minus ln e minus 1. Plus e cancelled, we still have 3 minus 2. Plus 3 minus 3 equals 0. It means that 1 over e is the unique root of u of x equals 0. Okay, if we take the equation u of x equals 0, it means that x equals 1 over e, and 1 over e is the unique root because the function is strictly increasing. Show that there is only one point on C where the tangent is parallel to the straight line delta y equal 3e square x minus 1. Assume that x is the abscissa of this point. Maybe 1 point, maybe 2 points. Let x be the abscissa of a point on C where the tangent is parallel to delta. So f prime of x will be equal how much? 3e square. So 2 minus ln x over x square equals 3e square. So 2 minus ln x equal 3a square x square. Cross multiplication leads to ln x plus 3e x square minus 2 equals 0. E square x square is e x square, which means that u of x equals 0. U of x equals 0 admits a unique root 1 over e. Then there is only the value of x, the value of x of the abscissa of the point on C where the curve is parallel to the straight line delta is x equal 1 over e. There is a unique value of x. Then there is only one point on C where the tangent is parallel to delta. Determine under F the images of the intervals 1 over e square, e cube. 1 over e. This interval is subset in the interval 0 e square. And over e square, 0 over e square, f is strictly increasing, then f of 1 over e is f of 1 over e, f of e. Okay, the function is strictly increasing over 0 e square. F of 1 over e is minus 2e. Minus 2e, and f of e equals 0. So e squared e cubed subset e squared plus infinity, and over e squared plus infinity, f is strictly decreasing. Then f of e squared e cube is f of e cube, f of e square open, because at e square is open. 2 over e cube is f of e cube. F of e cube, we substitute x by e cube, then e cube is 3. 3 minus 1, 2 over e cube. F of e square equals 1 over e square. So this is 2e minus 3e minus 2. Consider the function h defined as h of x equal f of x. If x greater or equals to 1, then 2 minus x minus 1 if x less than to 1. Okay. Find the domain of definition of this function. We know that the domain of f is 0 open plus infinity. So f is defined over 1 closed plus infinity. F is defined for x greater or equals to 1. For ln 2 minus x minus 1, 2 minus x should be greater than 0. So x less than 2. X less than 2, for x less than 2, this function is defined. And if x less than 1, the function is also defined, because 1 is less than 2. The function is defined for x less than 2, it will be defined for x less than 1. So what will be the domain of definition? x greater or equal to 1 and x less than 1, it is R. Study the continuity and the differentiability of h at 1. The domain of definition of h equal R, so the function is defined over a neighborhood of 1. Over a neighborhood of 1. Limit h of x as x goes to 1 minus 1 minus h of x. If x less than 1, h of x is ln 2 minus x minus 1. X goes to 1. Okay? And here x goes to 1 minus because we choose the function ln 2 minus x minus 1. Substitute x by 1. Ln 2 minus 1. So ln 1. Ln 1 0, so this is minus 1. Limit h of x as x goes to 1 plus is limit ln x minus 1 over x as x goes to 1. Substitute x by 1. We got 0. Minus 1 over 1 equals minus 1. And h of 1 equals how much? H of 1, we calculate h of 1 from f of x. H of 1 equals ln of 1 minus 1 over 1 equals minus 1. So what do we conclude? Limit h of x as x goes to left hand side of 1 equals limit h of x as x goes to right hand side of 1 equals h of 1. Then h is continuous at 1. The differentiability. So we calculate limit h of x minus h of 1 over x minus 1 as x goes to 1 minus. As x goes to 1 minus, h of x is ln 2 minus x minus 1. Ln 2 minus x minus 1. Okay? And h of 1 is minus 1. H of 1 is minus 1. Minus 1, this is plus 1. Plus 1 minus 1 cancelled. We still have ln 2 minus x over x minus 1. If we substitute x by 1, we got ln 1 0 over 0. We use Hopital's rule. This is limit derivative over derivative. Derivative of ln u is u prime over u minus 1 over 2 minus x over 1. Substitute x by 1. 2 minus 1 1 minus 1 over 1. This is minus 1. Differentiability to the right hand side. Limit h of x minus h of 1 over x minus 1 as x goes to 1 plus. If x is greater than 1, h of x is ln x minus 1 over x. Okay. Minus h of 1. H of 1 is minus 1. This is plus 1. Making a common denominator, we got ln x minus 1 plus x over x into x minus 1. Okay. Common denominator and the numerator. Ln x minus 1 plus x over x. So this x comes down. X into x minus 1. If we substitute x by 1, ln 1, 0. x1, 1 minus 1, 0, and here 0. So we use Hopital's rule. Limit derivative over derivative. Derivative of ln x, 1 over x. Derivative of x is 1 minus 1, 0. So 1 over x plus 1 over, here we have a product, uv. The derivative is u prime v plus uv prime. So this is x minus 1 plus x. 2x. If we substitute x by 1, this x 1 minus 1 cancelled, we still have 1. 1 over 1 1 plus 1 2. Limit h of x minus h of 1 over x minus 1 as x goes to 1 plus is different from the limit of h of x minus h of 1 over x minus 1 as x goes to 1 minus. Then the function is not differentiable at 1. Set up the table of variation of h and construct its representative curve omega in orthonormal system. We know the table of variation of h over 1 plus infinity. Over 1 plus infinity, the table of variation of h is the same as f. Over minus infinity 1. Over minus infinity 1, h of x is ln 2 minus x minus 1. h prime of x h prime of x, this is minus 1 over 2 minus x. The derivative of minus 1 is 0. 2 minus x is a positive over 1 plus infinity. Over 1 plus infinity, this is a positive. Minus 1 over 2 minus x is negative. So the function h is strictly decreasing over minus infinity 1. Limit h prime of x as x goes to minus infinity equals 0. Here the limit is 0. Minus 1 over infinity, this is 0. Then the curve of h admits an asymptotic direction parallel to x prime x at minus infinity. Ln 2 minus x minus 1 equals 0, and the intersection of the curve with the x-axis leads to ln 2 minus x equals 1 equals ln e. 2 minus x equals e, so x equals 2 minus e. 2 minus e, 2 minus e belongs to, this is a number less than to 1, less than to 1. So this value is accepted. 2 minus e is negative. So x minus infinity 1, e squared plus infinity. h prime of x over minus infinity 1, the function is strictly decreasing. So this is plus. Here we have plus. And over e squared plus infinity minus. So this is decreasing. Limit h of x as x goes to minus infinity equals plus infinity. Why plus infinity? Because ln 2 minus x as x goes to minus infinity, 2 minus x plus infinity, ln plus infinity plus infinity. F of e square is 1 over e square. Over 1 equal minus 1. The function is continuous at 1. Decreasing, increasing, decreasing. Okay. This is the number 2 minus e, 2 minus e. This is the number e, the curve of the function, f cuts x prime x at e, because if we take f of x equals 0, ln x minus 1 equals 0, ln x equals 1, x equals e, x equals e. This number is e. 2 minus e, this point is 1 minus 1, 1 minus 1. This point is the corner point of the curve. Let us construct the curve over minus infinity 1, over minus infinity 1. The function is decreasing from plus infinity, and it admits, the curve admits an asymptotic direction parallel to x prime x, like this. And over 1 over e square, and 1 over e squared, increasing, increasing, and the curve passes through, cuts x prime x at e, comes to this point. Here we have a tangent parallel to the x-axis. Then the curve goes to minus to 0 along x prime x, because x prime x is an asymptote. The point 1 minus 1 is a corner point. Thanks for following and good luck.